Ever heard a developer say, "It works on my machine"? That phrase basically funded the creation of Docker. Think of a container like a shipping container on a cargo ship. It doesn't matter if it's on a truck, a train, or a boat. The contents stay the same. Spotify, Netflix, and Google all use containerization to ship code faster and sleep better at night. Think of Docker like ordering from a restaurant. You're the CLI placing the order, the daemon is the kitchen actually cooking, and Docker Hub is the giant recipe library out back. Netflix uses this exact architecture to spin up thousands of containers on demand without breaking a sweat. So when you type Docker run, you're not running a container, you're asking the daemon nicely to do it for you. Think of Docker run Hello World as the hello world of containerization. It's the handshake that proves your entire Docker engine is wired up correctly. Spotify's engineering team uses this same setup flow when onboarding new developers, getting them container-ready in under 10 minutes. If that Hello World output shows up, you're officially in business. Most people assume containers are just lightweight VMs, but they're fundamentally different. A VM carries an entire OS weighing gigabytes, while a container might be just a few megabytes with zero boot sequence. Think of it like the difference between buying a whole new house versus renting a furnished room in one that already exists. This is why you can spin up hundreds of containers on a single laptop without it catching fire. Like a parfait, each layer is a frozen ingredient, and Docker just stacks them in order. Netflix uses this exact layering system so their app containers share common base layers across thousands of deployments, saving massive storage and download time. So when you pull an image you've partially downloaded before, Docker skips the layers it already has. Pretty clever, right? Think of Docker Hub like the App Store, millions of pre-built images ready to download with one command. Netflix uses official Node and Nginx images as base layers to ship services fast, rather than building from scratch every time. Notice how Node 20-Alpine grabs a lightweight Linux variant. That colon is your version selector, and it's more powerful than it looks. Think of a Docker file as a recipe card. It tells Docker exactly how to assemble your app's environment from scratch every single time. Spotify uses this exact pattern to ensure their Node.js services run identically in dev, staging, and production. Notice how we copy package.json before the rest of the code. That's a layer caching trick that can shave minutes off your build times. Imagine downloading a second app and realizing it barely took any space because it reused the OS layer your first app already had. That's exactly what Docker does. It's like two recipes sharing the same pantry ingredients, instead of each buying their own groceries. This layer sharing is why Docker feels so lightweight compared to spinning up full run like hiring a contractor. They show up, do the job, and you can send them home with Docker stop anytime. Netflix uses this exact pattern to spin up and tear down thousands of containers per day as traffic shifts. The key insight? Stopping a container doesn't delete it. That's Docker RM, so you can always bring it back like nothing happened. Think of Docker logs as your container's black box recorder. When something crashes at 3 a.m., this is the first place Netflix scale engineers look. The -f flag follows logs in real time, just like tail F on a regular Linux process. And Docker inspect is your secret weapon. It dumps everything Docker knows about a container, from network settings to environment variables, all in one JSON blob. Think of Docker exec as knocking on the door of a running container and stepping inside. The container keeps doing its job while you poke around. Netflix uses this pattern constantly to debug live microservices without ever stopping them. The niset flags are your best friends. Nisi keeps stdin open, T gives you a real terminal so it feels just like SSH. Most beginners assume stopped means gone, and panic delete containers thinking they're cleaning up. But a stopped container is more like a hibernating laptop than a crashed one. Your files, logs, and state are all still sitting there. It's only Docker RM that actually wipes it out, which is why so many developers accidentally hoard dozens of stopped containers eating up disk space without realizing it. For network types like different types of phone plans, some keep you local, some go nationwide, and one just turns your phone off entirely. Spotify, for example, uses overlay networks to let microservices talk across dozens of servers as if they were next-door neighbors. Picking the wrong network type is like trying to make an international call on a local-only SIM. Things just won't connect. Think of a Docker network like a private office Wi-Fi. Only devices connected to it can talk to each other. Notice how the app connects to PostgreSDB using just the container name, not an IP address. Docker's built-in DNS handles the translation automatically, exactly how services like Airbnb wire together their microservices internally. Why memorize IP addresses when container names just work? Think of your container as a building with no windows. P cuts a window and says, "Port 8080 on your laptop talks directly to port 80 inside." Netflix does exactly this pattern at massive scale, mapping thousands of container ports to host interfaces. Without this flag, your app runs perfectly inside the container and remains completely invisible to the outside world. Most beginners assume they need to expose ports everywhere just to get containers talking, but Docker's internal networking is more like a private office LAN. Colleagues can chat freely inside, but you only open the front door for visitors from outside. This means your database container never needs to be reachable from the internet at all. It just quietly listens on the internal network for your app container. It's a huge security win hiding in plain sight. Like a hotel room, you can rearrange the furniture and leave stuff on the desk, but housekeeping resets everything after checkout. Netflix learned this the hard way, scaling microservices. Any state stored inside a container is gone on redeploy, which is exactly why Docker volumes exist to give your data a permanent home outside the container lifecycle. So the big question is, where should your database actually live? Think of a Docker volume like a USB drive. You can plug it into any container, unplug it, and your data is still there. This is exactly how companies like Shopify persist their database state across deployments without losing a single customer record. Without volumes, every time you kill a container, your data dies with it. So would you really want that for your production database? Bind mounts are like punching a hole between your laptop and the container. Your local folder and the containers folder become the same folder. This is exactly how companies like Shopify wire up local dev environments, so engineers edit files in VS Code and see hot reload happen inside a container without ever rebuilding the image. Why would you ever copy files back and forth when you can just share them in real time? Most people assume that when a container dies, everything inside it disappears. That's literally the whole ephemeral container story we're told. But named volumes are like a safe deposit box that outlasts the bank branch. The container is gone, yet your database files, uploads, and configs are still sitting there waiting. This is why production systems don't lose data on redeployment, but it's also why developers who never run Docker volume prune slowly watch their disk space vanish into a graveyard of forgotten volumes. Imagine you're a conductor. Instead of hiring each musician separately every night, you hand one score to the whole orchestra and they just play. That's Docker Compose. One Docker Compose.yml file that wires together your app, database, cache, and anything else in a single shot. Without it, you'd be manually running 5 Docker run commands, configuring networks by hand, and crying into your terminal. This single file is the entire blueprint for a real 3-tier app, the same pattern Airbnb and thousands of teams use to wire together web, app, and database containers. Think of it like a recipe card. Instead of barking instructions at 3 different chefs separately, you hand them all one card and say, "Go." Notice how the app service just refers to DB by name. Docker Compose creates a private network so your containers find each other automatically, no IP addresses needed. Imagine your Shopify on Black Friday, traffic just spiked 10x, and you need more web workers right now. That's exactly what scale web equal 3 does. It spins up 3 identical copies of your web service behind the scenes without touching your code. Why redeploy your whole app when you can just tell Compose to clone the containers that matter? Most developers assume horizontal scaling requires cloud infrastructure, load balancer configuration, or DevOps expertise. But Docker Compose quietly lets you spin up multiple replicas of any service in seconds, right on your local machine. It's the same concept powering massive production deployments, just sitting there in your Compose file the whole time, waiting to be unleashed.